Hi guys, my name is Terry. In this video, we're going to go through the SPM trial paper year 2024. This is Melaka paper 2. Okay, so let's begin with question number 1. Now, this is from Form 4, Chapter 3, System of Equation, and this is solving linear and with a non-linear equation. In this question, you're given a diagram that shows straight line 3x plus 2y equals to 1 that intersect the curve 3x plus y squared equals 16 at point A and B. So you're supposed to find coordinate point A and B. So in deciding how to solve it, remember we are solving using substitution. We normally take the linear sub inside the non-linear. But the thing is, I can probably make x a subject or y as a subject. So the two things I already mentioned to my student is that you want to have fewer substitution and also avoid fraction. Now, if I make x a subject, I will have fraction because it's going to divide by 3. If I make y a subject, I will also have to divide by 2. You still have to have a fraction. But when talk about fewer substitution, right, actually both you have to substitute once. But if you sub y, you have to square it. So it makes it a bit more difficult. If I sub x inside, I don't have to square it. So you can actually solve it easier, right? So let's start by making x as a subject. 3x equals to 1 minus 2y. Now, in fact, you can actually substitute 3x directly inside because this is by itself is 3x, okay? But anyway, I'll just make x as a subject. So you have 1 minus 2y divide by 3. Okay, call this equation number 1. And we take 3x plus y squared equals to 16. Call this equation number 2. So we're going to substitute equation 1 inside equation 2. So there's a 3 and a 1 minus 2y over 3. Replace that into your x plus y squared. The result is 16. Now notice you can cancel 3 and 3. You're left with 1 minus 2y plus y squared equals 16. So it's kind of an easier, equation, right? So you get y squared minus 2y. 16 you bring over. 1 minus 16 you get 15. So let's work out the factor of 15. Factor of 15, 15 and 1, 5 and 3. The combination that gives us 2 is 5 and 3. So I'm going to put the double bracket over here. You have y and y, 5 and 3. In order to get -2, the bigger number 5 must be negative. Smaller number 3 must be positive. So my y is either -3 or 5. Take these two y value, sub inside equation 1. My x is 1 minus 2 times -3 over 3. That gives us 1 plus 6, 7, 7 over 3. And the second one is 1 minus 2. Your y is 5. Divide by 3. 1 minus 10, negative 9. Divide by 3. X is -3. Now here you're going to decide which one is x, which one is a, which one is b. You notice on your diagram, a is on the left-hand side. So a ought to be -3. B is on the right-hand side. The x coordinate should be positive, which is 7 over 3. So here we write the coordinate point A is -3. That's your x value. Your y value is 5. And your coordinate point B, your x value is 7 over 3. Your y value is -3. Yeah, based on the diagram, you can see we decide which is which. So let's continue to question number 2. This is from Form 4, Chapter 2, Quadratic Function. Okay, you have a quadratic function here that has a minimum value of r squared plus 2k, where r and k are constant. So they say by using the method of completing a square, show that r is k minus 1. Okay, so we begin from here. We are given fx equals x squared minus 6kx. So the 10k squared plus 1 we leave it later. So remember, to complete the square, you're going to add a constant. That constant should be half of this coefficient, -6k. Half of it, we just divide by 2. We square it. So we first add, then we subtract, and then you add whatever remaining terms at the back, 10k squared plus 1. Now, the very reason why we add this number is that we're going to combine these 3 into a bracket square. If you have x squared, you square it, you get x. Minus 6k, you divide by 2, you get minus 3k. We can write this minus 3k right away. And this is minus 3k. The moment you square it, is positive 9k squared. But remember, there's a negative outside. So we write a negative outside here, negative 9k squared plus 10k squared plus 1. Since we can simplify further, the minus 9k squared plus 10k squared is 1k squared, right? So you have k squared plus 1. So with that, we know that the minimum, this is minimum, the minimum value is the one outside the bracket, which is k squared plus 1. And this is equals to the minimum value given here, which is r squared plus 2k, right? So we are supposed to find r in terms of x, show that r is k minus 1. So I'm going to throw your 2k to the left-hand side. You will get k squared minus 2k plus 1. As we can factorize this is k minus 1 squared. If your r squared is equal to k minus 1 squared, r is just k minus 1. Just square root it. Yeah, and for those who don't know how I factorize this quickly, this is a squared plus 2ab plus b squared. Notice if the first and the last term are in what we call a perfect square, we can factorize them directly into a plus b squared. So here we have k squared and 1. You can see here this is k squared, this is 1. When you square root, you get k and 1. Now, to determine whether it's plus or minus, you look at the middle term. The middle term is negative 2, right? It should be negative 1. Yeah, this should be half of what we have on top, minus 2k. All right, so with that, after you square root, you get your r equals to k minus 1. Yep, we have shown that r is equals to this. Yeah, k minus 1. Now, next, we need to find the value r and k. If the graph of function is symmetrical about this, r is now, x is now r squared minus 1. Your axis of symmetry, actually, we can find from here, from this equation. We know that the minimum occurs when the one inside the bracket, which is x minus 3k equals to 0, your x is 3k. This is what we call your axis of symmetry. And we want to equate this with your r squared minus 1. So we write 3k equals r squared minus 1. We can call this equation 2. Go back to the first information that we got earlier. We call this equation number 1. What we need to do is to solve them simultaneously. Yeah? So let's sub 1 in 2. My r is now k minus 1. You square it minus 1. Let us expand k squared to k plus 1 minus 1. Your 3k is k squared minus 2k. Bring it over, k squared minus 5k equals 0. Factorize. You only have 2 terms, so no need to double bracket. Yeah, just take out common factor k. Your k is either 0 or 5. Now, if you have 2 answers for k, you should have 2 answers for r. So to find the r value, we just sub inside equation 1. Your r is either 0 minus 1, which is negative 1, or 5 minus 1, which gives us 4. Yeah, 2 answers for k and 2 answers for r. Let's move on to question number 3. This is from Form 4, Chapter 1 function. So here, the first part A, we have a modulus graph of function 3 modulus of 3x minus 2. Now you notice that the graph, right, they intersect the x-axis here, and so the meaning it passes through point n0. Okay, your x at x-axis, your y is 0, right? So we can substitute this coordinate inside your function. You can write your gx as your y, so it's 0, and your x as n minus 2. And by right, whenever you open up modulus, we should put a plus minus, but plus minus 0 is still 0. So my 3n is 2, n is 2 over 3. Okay, so that is the first answer. It's only 1 mark. Now, next, look at part B. We're given a function fx and f2x, what we call a repeated function or iterated function. So we are putting fx inside fx. Yeah, f2x is ffx. So we're going to calculate by putting fx px plus q inside px plus q. Okay, think bracket, f bracket is p bracket plus q. If we put px plus q here, we need to substitute px plus q here as well. So you have a p bracket plus q and bx plus q. So let us expand the bracket. B times b is b squared x. B times q is bq plus q. So this is your f2x, and we want to compare the f2x that we got here with your 4x plus 9. Now, we can use comparison. We first compare the coefficient of x. So the number in front of x is b squared and is now 4. You take square root of 4, answer is 2. Now, by right, I should put a plus minus, but it's given here that your p is more than 0. So we ignore the negative, take the positive, p is 2. Then you compare constant. Constant is the one without any x. In this case is pq plus q. And your answer must equals to 9. Now let me highlight for you is the purple one, right? Now with that, we substitute p with 2, put 2 inside. 2q plus q is 9. 2q plus q is 3q. 3q is 9. Q is just 3. Okay, so that is part B. Now moving on to part C. So here we have a composite function. When you're given x map onto y onto z, you can see function f occur first, followed by function g. Now we're supposed to find the value unknown a and b given function fx equals to ax minus 2. So what we can do is we can substitute your x with 4, your f with 22. So let's put 4 inside. The result equals 22. Yeah, so a times 4 minus 2 is 22. A times 4 is 4a. Bring the 2 to the right hand side, you get 24. A is 6. Then we move on to finding b. Now b, you got to look at g. Your g y is 12 over y minus b. When you put 2 inside, you should get 12, right? So we write 12 divided by your y is now 2 minus b. The result is 12. So I'm going to bring the 2 minus b up, bring the 12 down. 12 divided by 12 is going to give us 1. So your b is now 2 minus 1, which is 1. All right, lastly, you're finding the function that map z onto x. Sorry, x onto z. X onto z means the function that occur first is f, followed by g. So we write this as g. This is C Roman 1, C Roman 2, GFX. Yeah, GFX means fx happens first. Now that I know my fx, right? I know my a is 6. I put 6 inside. You should get 6x minus 2. Okay, that 6x minus 2, we substitute inside your g. Your g will be 12 over, your y is 6x minus 2, your b is 1. You get 12 over 6x minus 3. Now notice we can simplify further by dividing top and bottom by 3. 12 divided by 3, you get 4. 6 divided by 3, you get 2. 3 divided by 3, you get 1. So your GFX is now 4 over 2x minus 1, where x is not equals to half. Now remember, a function becomes undefined when your denominator is 0. So here my denominator is 2x minus 1, right? You cannot let 2x minus 1 be 0. So you bring over, you divide by 2, your x is half, right? So normally we have to write your x not equals to half. Your x can be any number except half here. Okay. Okay, moving on to question number 4. This is from Form 4, Chapter 5, progression. So this is an arithmetic progression. Here we are given that 3 right angle triangle with the measurement. You can see a k plus 1, k plus 2, and so on. So you're supposed to show that the area triangle form arithmetic progression, and then find the sum first n term if your k is 4. Okay, now let's find out the area triangle. Area of the first triangle, we call it D1. We use half times base times height. Your base is k, your height is also k. That gives us half k squared. For the second triangle, we use base of k plus 1. Your height is also k. So you can think of it as half k times k plus 1. Maybe it's easier. You write k first. It's easier to see. Followed by k plus 1. Half times height times base. Yeah, doesn't matter. So this will be half k squared plus half k. Then your third triangle will be half times k and k plus 2. Again, expand it, you get half k squared plus half k times 2. Answer is just k. Now remember, to show that it is arithmetic, right, we need to show that they have what we call the same common difference. So we take t2 minus t1. My t2 is half k squared plus half k minus my t1 half k squared, right? That will give us just half k. Then we continue with t3, we minus t2. Your t3, the third term, is half k squared plus k. Your t2 is half k squared plus half k. So when you expand the bracket, I don't have to write one extra step. Multiply negative inside. Half k squared minus half k squared is gone. K minus half k is also half k. Now you can see that since t2 minus t1 gives us the same value as t3 minus t2, therefore we say this is an arithmetic progression with common difference of half k. Yeah, your common difference is half k. All right, so that is how you show it. Okay, but we're not done yet. We're supposed to find the sum of the first n term, given that your k is now 4. So if your k is 4, so what is your first term? Your first term a is half of 4 squared. 4 squared is 16, half of it is 8. And how about your common difference? My common difference itself is this, is half k. Since I know k is 4, half of 4, your common difference d is just 2. And from here on, we need to find the sum of the first n term. We're finding Sn. Yeah, the formula will be n over 2 to a. My a is 8 plus n minus 1 d. D is 2 as well. Now, you can simplify the one inside the bracket first if you want. For me, I can see that the half I can cancel the 2 here. I can times inside as well and cancel the second 2 over there. That makes my calculation easier. So this would be n with the 8 plus n minus 1. So 8 minus 1, that would be 7. I just put this at the back. Expand the bracket. You should get n squared plus 7n. Okay, that is your part A. All right, part B. So I'm going to do over here. A piece of string with a length of 45 meters is cut into several pieces such that the length of the pieces form an arithmetic progression. So the length of the shortest piece and the longest piece is 50 cm and 40 meters respectively. So find the number of pieces of string that are cut. Okay, so shortest and the longest. Shortest piece would be your A, 50 cm. Longest piece will be your L or your TN, last term, is 400 meter, 4 meter, which is 400 cm, right? And if you add all the length together, the length should be 45. In cm is 4,500 cm, right? So I'm going to use n over 2 A plus L because this is easier because I know my last term. So you don't have to find your common difference, right? So to find n, okay, let's count. We take 4,500. This is 4,500. You multiply by 2, right? Then you divide by 450. My n is just 20. Okay. Okay, question number 5. This is from Form 5, Chapter 2, Differentiation. So here we have a milk that is poured into a hemispherical bowl radius of 4 cm at a rate of 3 pi cm cube, right? And if the depth of the milk in the bowl is h, volume is given by this, you're supposed to find the rate of change of h when the depth is 3 over 2. So if you're finding the rate of change of h, here we are given dVdt, volume of milk that is poured inside. You are finding dH dt. Before you find dH dt, you gotta, okay, maybe I write down the chain rule, break it up, dH dt, put the dV, put the dV. You already know dV dt. I can sub inside. You need to find dH dV. Well, dH dV, we actually find from here, from your volume V in terms of H we differentiate. So let's differentiate dVdh first. Now, if you have a constant pi outside, just leave it outside pi. Differentiate 4h squared, you get 8h minus the power 3 you bring down. There's a 3 here. Okay, now if you can't see, let me write bigger. Is volume equals pi 4h squared minus h cubed over 3. So when you differentiate, some people, they multiply the pi inside, they differentiate one, but it actually doesn't really matter. Just keep the pi outside. Yeah, differentiate inside. Differentiate 4h squared, 4 times 2 is 8. H, differentiate this, bring the 3 down, copy h, reduce the power by 1. You notice the 3 and 3, you can cancel, you're left with h squared. Now, then we want to substitute h with 3 over 2. Your dV dh is therefore pi 8 times 3 over 2 minus 3 over 2 square. So let's simplify. You can use a calculator. 3 over 2 is 1.5. So 8 times 1.5 minus 1.5 square. That will be 39 over 4 pi. Now, we're not done yet. We are supposed to find dH dt. So I'm going to use the chain rule above here, this one, the chain rule here. We know dV dt is 3 pi. Your dH dV is basically 1 over of dV dH. So just invert them. You get 4 over 39 pi. Then you multiply with your dV dt, which is 3 pi. We can cancel them, right? Pi and pi can cancel. 39 divided by 3 is 13. So your answer is 4 over 13. The unit actually don't have to write, but if you want to write is cm per second, because all this measurement you can see here is in cm and second. Okay. All right. Now moving on to part B. Maybe I do it over here, part B. Or should I do it below here? Okay, I do it below here. Okay, so for part B, you are given the radius of the surface of the milk is r equals to square root. So for square root, right, I'm just going to put this as power half. So when we differentiate dr dh, you bring the power down, copy the bracket, reduce the power by 1 negative half, differentiate inside the bracket. When you differentiate 8h, you get 8. Differentiate h squared, you get minus 2h. Now let's simplify further. The half and 8 you can cancel. 8 times half is 4. This one is 1h. You cancel it. I just rewrite this as 4 minus h over square root. Because remember, power negative means 1 over. Power half means square root. Power negative half means 1 over square root. Yeah. So in this case, since you have power negative half, I'm going to bring it back down. You're left with square root of 8h minus h squared. So that's your dr dh. So to find your r value, you're supposed to find the small change in the radius, your delta r. We need to first find your dr dh when your h is 1. So when your h is 1, you substitute 1 inside. This will be 8 times 1 minus 1. Now, not a nice number because it's in the form of square root, right? 8 minus 1 is 7. So it's 3 over square root 7. Now, how about your delta h? They say that h actually reduces by 5% from 1. When you reduce by 5%, it's a negative 5 over 100 times 1. That is negative 0.05. Okay, let me continue below here. No space. Maybe I do it below here. So the formula is this. If we say normally we use the delta y delta x equals to dv dr dy dx. Okay, this is dy dx. Okay, but this is not r. This is not y, not x. So we write maybe I start with delta r delta h equals dr dh. So it actually looks something like this. Let's say the curve looks like this. We just do a sketch. When your initially your h, okay, maybe I draw a bit bigger, a bit hard to see, too small. I draw bigger here. So initially, there's a line that touches the curve at one point. That's your h here. Your h is 1. Now your h reduces from 1 to a small value, which is delta h is negative 0.05. So when your h reduces, your y can be increasing or can be reducing. Okay, maybe my diagram is not right. I should draw the diagram in this direction because the gradient is positive. So I draw like this, it's better. Initially, it is h. It is 1. So your delta h is negative 0.05. So it reduces to 0.95. So your delta r, we need to find. Okay. Your delta r, I don't know. Your delta h is negative 0.05. Your drdh, which is this value here, this value here, 3 over 7 is your gradient. So we let it be equals to this. Yeah. Okay. Never mind. I just continue from here. I hope you can see this is the second part of part B. We just multiply this over, take 3 over square root 7, then you multiply with 0.05. The negative you can just add in later on. Just add in negative. Can put in here. Your answer is negative 0.05669. 669. Okay, that's it. That's your answer. Okay, this is question number 6. Is from Form 5, Chapter 1, Circular Measure. So we start off by finding the angle CAD. You're given two circles with center A and B. They intersect at point C and D. You're given the radius of smaller circle is 5, larger circle is 11, and they are both arc BC and line BC and BD. They are tangent to a circle. When the lines are tangent, right, means it touches the circle at one point. So let me draw like this. This is a tangent. That means it touches at one point, and it is 90 degree to the center, right? So this is a tangent. This is also a tangent, right? So it's a 90 degree here. So for me, I will redraw this bigger triangle for you to see. This is your CAB. Your AC is 5 cm. Your BC is 11 cm. You're finding angle CAD. CAD is the whole thing. So this is half of it. Maybe I just call this theta over 2. The whole thing is theta, let's say. Then CAB is theta over 2. So we're going to use SOHCAHTOA tangent, right? This is your opposite. This is your adjacent. This is your hypotenuse. We know our opposite and adjacent. So I use tangent theta over 2 equals to 11 over 5. Now you can actually tan inverse 11 over 5. Whatever you get, you multiply by 2. Now you can use your calculator in radian directly so that whatever you get is in radian. If you're using calculator in degree mode, then you get your answer in degree, then you got to convert to radian, which is a lot more work, right? And it's not accurate because why? When you use pi is 3.142, your answer again is a little bit more different from the actual answer. So for me, I'll take 2 tan inverse 11 over 5. Then I get 2.288. 2.288 correct to 4 significant figure will do, right? Yeah, don't have to give more. All right, once you got your angle theta, so the next thing is you are finding area of shaded region. Now you can see your shaded region, actually you can split this into 2. Split this in the middle. So it actually consists of 2 segments. This first segment, maybe I draw over here. This is the first segment. This segment, right? It has center at A. The radius is 5 and 5. This angle is your theta. Then you add a second segment, which is on the other side. Here, it's a bit longer. The radius is 11, right? This is your CBD, but I don't know what is this angle. Let's call it alpha. So one thing for sure, this is a quadrilateral. And since it's to a tangent, then 90 degree. So to find angle alpha, we will take total interior angle for rectangle or a quadrilateral is 2 pi. You minus 90 here, you minus 90 here. So you minus 2 of 90. So we write 90 in radian is pi over 2 times 2. Then you minus 2.288. So this will be pi. 2 pi minus 1 pi is pi. Pi is 3.142 minus 2.288. So you will get 0.584. 854, sorry. 854 radian. So once you got this, we know we can use area of segment. Remember, for those who do not know about this, right? This is a segment. A segment is a sector minus a triangle. If your sector is half r squared theta, your triangle, we can use half AB sine C. Your A and B, they're both R. So it's R squared sine theta over 2. Yeah, sine theta. So we take out the half and R squared. You're left with theta minus sine theta. So this is the formula for area segment. You can use this formula. It's a lot easier. So the first segment has radius of 5. Your angle is theta, which is 2.288 minus sine 2.288. Normally, we put a superscript R to indicate that this is a radian. Yeah, in radian. If you degree, you put a O R for radian. Then you add half. The second one is 11 square. Your theta, your alpha, in this case is 0.854 minus sine 0.854. So when you do this, remember to use your calculator in radian mode, right? So if you remember calculator, you can see the angle unit must be in radian. We take half, 1 over 2. Your radius is 5, square it. Your theta is 2.288 minus sine 2.288, close bracket. Then you add half again. Your radius is 11, you square it. Your theta is 0.854 minus sine 0.854. So you should get 25.23. Yeah, correct answer is 25.23. Okay. Okay, question number 7. This is from 5, chapter 6, a trigonometric function. So the first part is proving, second part is solving. So when they ask us to prove, right, we start from we can start from left and start from right. I think right-hand side is easier. Normally, we start from the side that has more number of terms, move on to the left-hand side, yeah, the one with less number of terms. Your right-hand side, there's a sine square on top. Now, remember basic identity, yeah? Cos square plus sine square is always 1. So if I bring this over, your sine square is actually 1 minus cos square. So I'm going to use this result and substitute inside. This is 1 minus cos square divided by 1 minus cos theta. Your 1 minus cos square is in the form of a square minus b square. When you factorize, it's going to give us a plus b, a minus b. Yeah? That is 1 plus cos followed by 1 minus cos divided by another 1 minus cos. Now we can cancel these two. Everybody cancel these two. Then you are left with 1 plus cos, which is the same as your left hand side. That's all, fairly easier. Yeah, for 3 marks. I think it's supposed to be 2 marks and not 3, yeah? Too short. Okay, part B, we're supposed to sketch a graph. So now for graph sketching, right, I'll show you one by one how it actually transform to this. The basic graph of cos, right, it looks like this. Cos x starts from 1, goes down to -1, comes back up to 1 at 2 pi. The moment you have a negative in front, so what happens is that the graph is reflected in the x-axis. So this is 2 pi, -1 to 1. Now, what if I have a 6 in front? So you're stretching it up by 6. So your amplitude is 6, maximum 6, minimum -6. And lastly, because you have a 2 in front of x, your number of cycles is now double from 0 to 2 pi. So we're going to draw a lot longer like this. So you draw, basically one cycle has 4 segments of 4 curve, if you like, forward. So 2 cycles, you should have 8. So I'm gonna move on and put 8 here. Okay, double the number of cycle. So we start from -6 to +6. Start from here, up, up, down. Just put on the marking first, so that you maintain a nice curve. Yeah, because some people, they draw the curve like this, like too big, too small, or slanted, right? So you want to maintain a balanced, a uniform shape, right? So you plot the point first, right? Then we draw a curve. Another thing is to hide the ugliness, yeah, we use a thicker pen. Use a 2B pencil if you like, or if you can. Not mechanical pencil. And please don't use pen, very dangerous. You cannot rub, right? If you make a mistake. Small curve here, yeah. Down, up, up again. Okay, this is ugly. So there you go. Yep. My graph is done. Okay, so just label this is your 2 pi. This is pi. As we subdivide it, becomes pi over 2. This will be pi over 4, 3 pi over 4, 5 pi over 4. This is 3 over 2 pi. 6 over 4 is 3 over 2, 7 pi over 4. And I think that's it. Yeah. Okay. That's my graph. Okay, this is question number 8. The first part is from Form 5, Chapter 2, Differentiation. Second part is a combination of differentiation and integration, right? Form 5, Chapter 2 and Chapter 3. The second part, Part B, is from Form 5, Chapter 3, Integration. Okay, so let's begin. So they say for Part A, the tangent to the two curves has gradient of this and this. And the two curves intersect at the right angle at 2, 3. Calculate the value P. Okay, when two curves intersect at the right angle, right? Meaning, maybe we can draw, I don't know, the first curve like this, right? Second curve also just a sketch. This is your first tangent. This is your second tangent. Second curve like this. They both intersect at the right angle. So the gradient of the first curve at point x equals to 2, your dy dx, let me write down, your dy dx is 4x minus 5. When x is 2, 4 times 2 minus 5, you get 3. The second one, your dy dx is px minus 3. When x is 3, p times 3, we write 3p, 3p minus 3. Now, these two gradient, they're perpendicular. These two tangent, they're perpendicular to each other. So your m1 times m2 must be -1. Our job is to find p. So multiply inside. 9p minus 9 equals to -1. 9p is 8. Wait. Did I make a mistake here? Oh, you substitute x with 2. Sorry. Your x is 2. This is 2p minus 3, not 3p minus 3. Sorry. That's why it looks a bit weird. So this is 6p minus 9. If you bring over, 6p is now 8. P is 4 over 3. That is a Roman 1. So for a Roman 2, you're supposed to find the equation of the curve when the tangent with the gradient of tangent 4x minus 5. So to find the equation curve, you're going to integrate your dy dx, which is 4x minus 5. This is going to give us x power 2. 4 divided by 2, I write 2 straight away. Integrate 5, you get 5x plus c. So to find the value of c, we submit a point that it passes through. In this case, 2, 3. We know it passes to 2, 3. Your y is 3. Your x is 2. Find your c. So this is 3. This is 8 minus 10, -2. My c is 5. Therefore, my equation of the curve is just this. Okay, that is part A. All right, moving on to part B. So I'm going to continue right below here. Now, the first thing is notice that you're given this shaded region. The curve has this equation square root of x plus 6 and straight line x equals to k is a vertical line. And you're given straight line AC is a vertical line passes through 3. This one is k. And area shaded region here is rotated through 360 by x-axis. The volume generated is 4 42.5 pi. So when you rotate, right, you actually get a cone here. And the second one, you get a curve like this. So it's actually volume of integration minus volume of cone, right? Your integration, remember you have to square the y, pi x squared dx. When you're pi y squared dx, when you're rotating about x-axis is pi y squared dx. Your y itself already has a square root here. You square it dx. The lower limit is 3, upper limit is k. Then you minus volume of your cone. Now your cone has a formula for volume of cone is 103 pi r squared h. Your radius is actually measured from here to here. To find that radius, right, you need to calculate separately, yeah? Because when your x is 3, right, find your y. You put 3 inside. 3 plus 6 is 9. Square root 9, your y is also 3. So notice this is also 3. Your cone has a radius of 3. You got to put the 1 over 3 pi r square. Your height of the cone is measured from here to here, which is k minus 3. And your answer is 42.5 pi. Okay, I need to simplify further. Now, maybe we can just get rid of pi first. Divide everybody by pi. Okay, don't need to write the v here, volume here. Cancel the pi. And I will square this first. This is x plus 6. Right? You can just write x plus 6. X plus 6 dx. This one, 3 square is 9. Cancel, cancel. Pi already cancel out. There's a 3 and k minus 3. This is 42.5. 42 times 2 is 84. 84 plus 1, 85 over 2. Now, our job is to find k. Right? So we're going to integrate first. Integrate is x squared over 2 plus 6x. Lower limit is 3. Upper limit is k. Multiply inside minus 3k minus 9. Minus minus a plus 9. This is 85 over 2. Okay, let's continue. We substitute k inside is k squared over 2. 6 times k is 6k. 3 squared is 9 over 2. Maybe you should show your substitution. In the exam, they want you to show substitution. So show 1 by 1 minus 3k plus 9. 85 over 2. From here on, you can use a calculator to calculate. For me, okay, I'm going to do 1 by 1 first. Do slowly first, okay? I'm going to do all the numbers first. So 9 over 2, you plus 18. Yeah. There's a negative in front. So this is negative 45 over 2. Okay. There's a negative. So your 9 minus this answer. Then you bring the 85 over 2 to the left-hand side. So you should get 56, right? So, okay, there is a negative 56 over here. You still maintain your k squared over 2. Your 6k, you must minus 3k. You're left with another 3k. From here, we can multiply everybody by 2, get rid of fraction. This is 112. Double bracket, factorize them. What is a factor 112? Let's try out. So numbers a bit bigger, 112. Maybe we can use this to help us shift factorize. You can see it's actually the prime factors are 2 power 4 and 7. So 2 power 4 is 16. 16 and 7. So you work out the combination that gives us more 112, right? So 112 and 1 and so on. But for me, I look at 6, right? 6 is actually 14 and 8, right? Because your 2 power 4, you can break it up to 8 times 2. And there's a 7. So this is 8 and 14, okay? If you really cannot, you can just use a calculator. I know a lot, this is not a secret anymore. Everybody know this. Menu down here, equation, right? Then you go to polynomial, degree of polynomial 2, just key in this out. But you need to show you're working. Although you can factorize using a calculator, you get penalized for writing this directly. So your answer is 8 and 14. So I know it's 14 and 8. So, right? Show you're working. This is 8 and 14. In order to get positive 6, the bigger one, 14 is positive. 8 is negative. So k cannot be negative 14. K must be 8. How come? Because if you look at the diagram, your k is on the right-hand side of the y-axis. K is more than 0. Cannot be negative. So we ignore negative 14. Only take one answer. k equals to 8. Okay, moving on to question number 9. Now, this is from Form 4, Chapter 7, Coordinate Geometry. So here we have point S that move along the circumference of the circle with center P minus 1, 3. The circumference of the circle passes through point Q and R, right? So find equation of locus of point S. Okay, I think we can do a sketch. We draw a circle like this, right? The center of the circle P is minus 1, 3. It passes through Q. Well, I don't know where is Q. Perhaps it's here. Q is 3, 0. And your point R minus 4M. Now R, I don't know, maybe here, maybe above, but it should be to the left. Okay, so maybe I just draw here. R is minus 4M. So the first thing is we are finding equation of locus as S is a moving point. We can call it SY, XY. So it can be anywhere such that the radius, right, is the same as PQ. So let's do it here. We can say PS equals to PQ. Use the formula for distance. So, okay, sorry, PS. S is a moving point, X and Y, right? So you put X minus 1 square plus Y minus 3 square. PQ is a fixed radius, right? So we take square root of 3. You can write minus 1 minus 3. I write, okay, never mind. I'll just write minus 1 minus 3. Then minus 1 minus 3 square and 3 minus 0 square. So let's simplify this. This is X plus 1 square plus Y minus 3 square. This is negative 4 square, which is 16. 16 plus 9. 3 square is 9, which is 25. Square 25. This will be 5. But I'm going to square both sides directly. Get a fraction. Okay, get rid of square root. Square both sides. The square root disappears. Leave it as 25. Expand the bracket. 2x plus 1. Y square 6y plus 9. There's a 25 here. Rearrange. Normally we write x squared first followed by y squared and 2x 6y. 1 plus 9 is 10. 10 minus 25. You get 15. All right. That is part A, Roman 1. Part A, Roman 2, you are finding the values of M. Now, M is a random point here because your R negative 4M can be below here. It can also be above here. Okay, maybe because your negative 4 is the X value. Your X value is constant, negative 4. But your M value is an unknown. It can be above, it can be below. We don't know, right? So we need to take this coordinate and sub inside your equation of locus. That means your X is negative 4. You square it. Your Y is M. You square it. Plus 2 times negative 4 minus 6M minus 15. The result is equal to 0. Negative 4 squared is 16. This is M squared minus 8 minus 6M minus 15. Your M squared minus 6M. Your 16 minus 8 is 8. 8 minus 15 is negative 7. We double bracket factorize. 7, 1 minus plus. To get negative 6, you must use minus 7 and positive 1. Your M is either negative 1 or positive 7. So these are the two possible values of M. Now, next they say the tangent to the circle at Q cuts the y-axis at T. Cuts the y-axis at T. I don't know where's y-axis, maybe here, right? This is y-axis, this is T. Okay, when a line is a tangent to a circle, the line is perpendicular to the center of the circle. So we start by finding gradient PQ, right? Gradient PQ will be 3 minus 0 minus 1 minus 3. That is negative 3/4. Now, PQ is perpendicular to this tangent. This tangent is QT. So we can write negative 3/4 times gradient QT equals negative 1. QT is therefore positive 4/3. Then we form equation of straight line because we need to find out the y-intercept of this straight line. So we use y minus y1. Your y1 will be 0. I'm using 3, 0. Your gradient is 4/3 x minus x1. Your y is therefore 4/3 x minus If you times inside of 4, 3 times -3 is just -4. So your y-intercept C is -4. Therefore, coordinate point T is 0, -4. So I've got point P, I've got point Q, I've got point T. So let's use the formula for area triangle to find area triangle PQT. So we start with half P is -1, 3. Q is 3, 0. T is 0, -4. Repeat the first point. So let's multiply downwards. 1, 2, 3, minus multiply upwards. 1, 2, 3. So this is -1 times 0, 3 times -4, 0 times 3, 3 times 3, 0 times 0, -4 times -1. Show you're working, need to multiply one by one. So the first one is -12. Okay, -12, the 0 all becomes 0. Second one is -9 plus 4. So it's actually -12, -13, -25. Half of 25, 25 divided by 2 is 12.5. The thing is, the modulus, we can treat like a modulus because your area cannot be negative. But if you choose in the clockwise direction, it's going to be negative. If you choose anti-clockwise direction, your PQT, PQT here, if I choose PTQ, I'm going to get positive. PQT is going to be negative, but doesn't matter. Since area is always positive, we just take answer as positive 12.5. Okay. Okay, let's continue with the next question. This is question number 10. This is from Form 5, Chapter 5, Probability Distribution. So here we have a durian chosen randomly from several baskets. So the probability that a rotten durian is 0.1. Find the standard deviation. Okay, remember this is a binomial. Your P is 0.1. Your Q is 1 minus 0.1, which is 0.9. Standard deviation is NPQ with the square root. This formula is given. My n here is 500. You're choosing a sample of 500 durians. So we take square root of 500 times 0.1 times 0.9. Okay, use your calculator. 500 square root 500 times 0.1 times 0.9. You should get 3 set 5 or 6.708. 6.708. That will do a 4 significant figure. So that's part A. Okay, part B. This question is very similar to SPM 2006. Actually, they cloned it from that year. You still remember this question. So an orchard has produced mangosteen. Table 1 shows the grade of mangosteen according to the mass below will be exported to other countries. You have grade A, grade B, grade C. This is the mass. The heavier it is, the higher the grade, right? So we are given that if the mass of the mangosteen produced follow a normal distribution or normally distributed with mean of 260, standard deviation 35. So here mangosteen chosen random, calculate the probability that is grade A. So to find grade A, right? Grade A happens if the mass is more than 300. So we're going to standardize this. Change from X to Z, take 300. You minus your mu, which is 260, divide standard deviation 35. Yeah. So let's change from X to Z. Take 300 minus 260, divide 35. You will get 8/7 or 1.143. Give your answer correct to 3 decimal point, we do it because you cannot read more accurate than that, right? 1.143, 3 decimal point. Now, there are 2 ways to do this. We can use your calculator or you can use your table. Okay, so here I'm going to use a table first. I'm going to show you both, right? 1.143, the way we read this is 1.1, 4 is here, and to get 3, you move down, you can see there's a 6 here, right? We should subtract 6 from the last digit. This is 0.1271. You subtract 6. So you get 0.1265. Yeah, 1265. Okay, you can use your calculator to double check. But the way we use this calculator a bit different now. Let me show you here. You take menu 7. You go to number 2 for normal. Go for lower. Now, because your table is based on upper tier. Upper tier means from wherever it starts up to infinity, right? Up to positive infinity. Let me just show you here, you are finding 1.143 to positive infinity, but you cannot read infinity from the calculator. So normally you just put 999 or even 99 will do. Okay, so you go to lower as 1.143, upper will be 999. My answer is the same as 0.1265. Yeah, most of the time, 99% of the time you get the same answer. Sometimes there's a slight difference in answer, right, compared to calculator, right, compared to your table. So let me clear this, 1.265. Wait, let me clear this. Okay, go back to this answer. The probability is 0.1265. Okay, 1265. Okay, that is B Roman 1. Yeah, the probability of getting grade A. Now, next, a basket has 600 mangosteen. Estimate the number of mangosteen of grade B. Okay, grade B is between 200 and 300. So for 200, right, you got to minus your mean 260, standard deviation 35. 300 minus 260 divided 35. Actually, this one you don't need to count because you already know for 300 is 1.143 from the first part. Okay, but anyway, I've written already. So take 200, go back to your normal mode, mode 1. 200 minus 260 is negative 60. You divide by 35, you get 1.714. Negative, negative 1.714. Okay, this is Z. This is going to be the same 1.143. So notice if you do a sketch, like first one, right, it is on the right hand side, 1.143. This one is in between. It is in between. Let me draw it here. One is negative 1.714. Another one is 1.143. You're finding the in-between values. So when the shaded region crosses the halfway line, you need to use a 1 minus. 1 minus, flip this to the right, 1.714. Flip this, I mean, this one is already on the right, 1.143. For 1.714, you can use a table or you can use a calculator. Okay, let's say I use table first, 1.714. So 4, you move across, you say subtract 3, right? Subtract 4. Okay, 4, I circle the one below here. So it's 0.0436, you minus 4 from the last digit, you should get 0.0432. Yeah, 0.0432. Use your calculator, double check, right? Menu 7, 2, lower is 1.714, upper is 999. You should get 4326. Okay, notice it's a slight difference answer, right? Yeah, 432. So which one is a better answer? Actually, by right, calculator is more accurate, but a lot of time, most of the time, the marking scheme is based on the mathematical table because not everyone has this calculator, right? Even the older calculator also can calculate, but we don't use this function. We use the PQR function. So sorry, I don't have the emulator to show you here, right? But if you already know how to use that calculator, you can also go ahead. Now, 0.0432. I'm going to use this answer, 0.0432. Let's clear this. This is 0.0432. And this one, we got it earlier, 0.1265. So let's do 1 minus 0.0432 minus 0.1265. You will get 8303, 0.8303. Okay, this 8303 means they are 83%, around 83% of them are grade B. But we want to find how many grade B you have in a basket of 600. So we use the concept of simple probability. The probability of getting grade B is the number of grade B divided by total. Total here we use NS. What is NS? Size of your sample space. Yeah, that means you're basically, in other words, your total. Your probability of getting grade B is 0.8303. The number of grade B we don't know. The total is 600. So let us take 600 multiply by this answer. Okay, you should get 498.18. Yeah. So take the nearest 498.18. Take the nearest integer because your number of mangosteen must be integer, right? You can't have 498.18 not, you can't have half a quarter of mangosteen, just either 98 or 99. So in this case, we take 98 at the nearest integer. All right, that is part B. Okay, let's move on to part C. If 99% of mangosteen will be graded and sold, calculate the minimum mass in gram of mangosteen that can be graded and sold. Okay, 99% you can sell. This is from the orchard, right? Maybe 1% they are, bad enough. They are too small, right? And actually, you can see they say that they are graded according to grade ABC. So the rest you cannot grade, you cannot sell, right? So anything more than K, you can sell. That's 99% of them. So we standardize it. K minus mu, 260, standard deviation 35. Okay. This is 0.99. So when you do a sketch, right, we notice that this is supposed to be on the left. Yeah, K minus 260 over 35 should be on the left. So that 99% of them, or 0.99 probability of the chances is more than this. So remember, we need to do a 1 minus here. So here I'm going to write 1 minus PZ less than. It's less than and not more than, because it's the left-hand side. This is 0.99. So your probability of Z less than K minus 260 over 35 is 0.01. Very small value, meaning the one on the left here is 0.01. So you work backwards and find out what is the Z value. Okay, remember, most of the time, if you use your calculator or your table is based on the right-hand side. You can see? Right-hand side. So now we are taking the left-hand side. So then we just find 0.01 first. Very, very small value. Find from inside your table 0.01. Where is it? 0.01. The closest I got is 0.0102. So I need to subtract 2 from the last digit. If I move up, I will get 2.326. Yeah, 2.326. Hope we know how to read this. We are reading the Z value given the probability, 2.326. Okay, go back to this one, 2.326. Now, I can use my calculator to verify. This calculator is really good. You can do this. Other calculator cannot. Menu 7. Go to number 3 for inverse normal. Your area is 0.01. Your standard deviation is 1, mean is 0, 2.326. Now, however, calculator and table is a bit different, as in table is based on upper tier. Calculator is based on lower tier. That's why calculator has a negative here, right? So you have to take note that your K value here from my graph is on the left. If it's on the left, you need to assign a negative. If you put a positive, then your answer is different, it's wrong, right? So some zone they flip the right, but nowadays a textbook, they don't flip to the right, they leave it on the left. If it's left, just add a negative for your Z value. Okay, so now lastly, we use our calculator, negative 2.326. You times with 35, you plus with 260, find your K value. My K is 178.59. 178.59. If you round it off, is 178.6. Okay. Or you can even take 179. Okay. The question didn't mention, right? So I think we can just leave it as it is, right? But if you want to round off to the nearest integer, because all these are integer, right? You can write 179. Okay, this is the exact value. This is the nearest integer. Okay, but if the question don't mention, I think it's better to just leave it as 178.59. Okay. Okay, we're going to move on to question number 11. This is from Form 4, Chapter 6, Linear Law. So you're given a table here that shows the values of variable x and y obtained from experiment. They are related by this equation given here. P and Q are constant. So based on the table here, we're supposed to plot x, y against x squared, okay? And then draw the line of best fit. So number one, we need to recalculate what is your x squared and what's your xy? If your x is 2.5, 2.5 squared is 6.25. Can you use your calculator? 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. So for xy, I'm going to use my calculator here. I take 2.5 times 1.75. That will give us 4.375. But you don't need such an accurate answer. 2 decimal point is more than enough. So I'm going to take 4.38. 3 times 1.8 is 5.4. 4 times 2, I'm going to write 8. 5 times 2.5 is going to be 11.5. 6 times 2.6. 2.6, I'm going to get 15.6. 15.6, 7 times 3 is 21. Now, I'm going to use a calculator to predict my answer because you're going to get gradient and your y-intercept from the graph, but I can actually do it from the calculator. Let me show you how. Press menu, go to number 6 for statistic, go to number 2 for a plus bx, that is your linear form. So key in all the x value first, 6.25, press equals, followed by 4 point, do all the x first, 9, then 16, then 25, then 36, then 49. Yeah, key in all the x value. Okay, now then we move on to the y value. My y value is 4.38, followed by 5.4, 8, 11.5, 15.6, and lastly 21. Okay, so after you key in all the x and y value, you go to AC, press OPTN for option, go to number 3, regression calculator. So notice that your A value is 1.89. A here is your y-intercept. So your y-intercept is 1.89. You're supposed to get this. Okay, later we verify from the graph. Okay, your B is your gradient, 0.387. Your gradient is supposed to be 0.387. Okay, so as long as my answer is close to this is fine. Okay, now next we are going to draw the graph now. The question mentioned x, y axis, x squared, you use 10. X, y axis, you use 2. So let's start from the bottom here. This is 0. This is 10. So it's a very small graph. Okay, let me just zoom in a bit, hard to see. Very small as in narrow, because we only need up to 49, right? So this will be 10, 20, 30, 40, maximum 50. Yeah? We stop here. This is your x squared. So xy is 2, 4, 6, 8, 10, 12. We need to go until 21. 14, 16, 18, 20, maximum 22. So this is xy. Okay, let me draw the axis. Okay, zoom out a bit. This is your horizontal axis. Okay, let's draw the vertical axis from here all the way up. Right, there's a vertical axis. This is your xy. Okay, now we're going to plot in the coordinates. The first one is 6.25 and 4.38. Now you can't even read 6.25. You can read 6. You can read 6.5. So yeah, it's a bit hard to see. 6 and 4.38. 6 is around here. 6.5 is, because this is one small box, is 1/2 of it is in between. 6.5 is in between. So we just take the closest. We can just take 6, or in between also can. 4.3. Now your vertical axis, remember, one big box is 10, one small box is 2. 4.38, I think I have to read 4.4. 4.4 is 2 boxes, so you can plot here or slightly to the right also can, right? This is 4.4, the closest I can get. Now, next coordinate I have is 9 and 5.4. 9 and 5.4. 5.4 would be 3 boxes from 6, 5.4 around here. Next, we have 16 and 8. 16 and 8. Okay, followed by 25, 11.5. 25. Okay, you can't read 11.5. Can we? We can either read 11. Wait. We can 11.5. This is 11. 11.5 is just in between. And I need to read 20. Wait, 25. 25, 11.5. So 25 is in the middle, 11.5 also in the middle here. Okay, a bit small. Okay, next we have 36, 15.6. 36 and 15.6. 36 will be here. 15.6 should be around here. Is two small boxes below 16. All right, next 49 and 21. 49, 21. 21 is right in the middle. 49 is here. Okay, there you go. That's your points, all the points done. Okay, now one thing I know that my y-intercept supposed to be 1.89, or you can think 1.9. So we can fix the position here. Even if you use 1.8 is fine. Yeah. 1.9 is in between. So okay, let me take this first. We need to do some adjustment. We need to adjust this. Okay. This one looks quite nice. This is 2. Oops. This is 2. If I take this, this will be 1.8. I can also take a little bit higher. I think 1.8 is also okay. 1.9 also okay, right? But you want to make sure that it passes through all the points. I think this line is quite good. You can see here. 1 point, the first point is above. The second last point is below. The rest are almost on the line of best fit, right? So I think it's okay. I don't need to adjust it. So I'm going to take 1.8 as the answer. You can take 1.9 as well because it's in between, right? So I'll take 1.8. Now, that's my y-intercept. But you also need to find the gradient. So to find gradient, we just take any 2 points. Now, normally we take 5 horizontal. Horizontally, we take 5 boxes because any number divided by 5 boxes is always a nice number. But you notice that this one, you're going to go a bit higher, right? This coordinate here is 50 and 21.2. 21.2, all right. The one below here is 0, 1.8. Okay, so I'm going to calculate my gradient over here. You can write anywhere. So my gradient is 21.2 minus 1.8. Divide 50 minus 0. Okay, let me work it out here. Okay, menu 1. Go back to the normal mode. Menu 1. Take 21.2 minus 1.8. Divide 50. My answer is 0.388. Very, very close. The gradient is supposed to be 387. I got 388, which is fantastic. Yeah, very, very close. Okay. Now, of course, you can adjust the line so that your y-intercept is 1.9. Yeah, but it's half of the smallest box, so sometimes it will be hard to read. So I just take 1.8, right? 1.9 also okay. Right. If you get 1.9, then maybe you will get exactly the same. Let me just change this. Yeah, 386, 387, not exactly. Also okay, right? Yeah, 386, 387. So I'll take this 388. Okay. Now, coming back to your question here, you're supposed to find 2 things. You're supposed to find the value of y when x is 4. Okay, actually, if you look at this, the question says x squared equals 4, but the marking scheme uses x equals to 4. So either you change the question or you change the answer at the back. I mean, the marking scheme answer. So here, because x squared equals 4 is rather small, I will just take x equals 4. Guys, I just make the changes so that it matches the marking scheme given. So if your x is 4, your x squared is supposed to be 16. So from the graph, where is 16? Okay, I'm going to zoom in here. 16 is over here. Move it up. Move it across. It looks, wait a minute. Do I have 16 here? Oh, this is a bit weird. Yeah, I already have 16 here. Yeah, but this is the marking scheme answer. Okay, or should I just leave it as 4? Okay, I tell you what, it's better change to the original question because it's very weird, right? So it's okay. I'll just take x squared equals to 4. Yeah, so don't need to change the question because we already have 8 from the original value, right? So 16, we have 16 from the original value. So your x squared equals to 4. So read 4 from here. Where is 4? 4 is over here. Move it up. Move it across. It looks like in between. It looks like in between. So this is in between. This is 2. This will be 3. It looks like 3.3. Yeah, 3.3. Yeah. Between 3.2 and 3.4, 3.3. So from the graph, right? Go back to this one. From the graph, your xy equals 3.3. Since your x is 2, x squared is 4, x is 2, 2y is 3.3. My y is 3.3. Divide by 2, 3.3 divide by 2. I got 1.65. Okay, now how do you find the values of P and Q now? The next part, we need to use your equation P over X, Q over P plus X. Okay, your original equation is Y equals to Q over X plus, wait, let me see again. P over X, Q over P, X, P over X, Q over P times X. So we're going to multiply everybody by X because I need to get XY. So XY is now QP, X times X is X squared. The P, I put it back. Yeah. When you multiply by X, P over X becomes P, Q over P times X becomes Q over P, X squared. So this is now your big Y. Big Y represent the variable on the Y axis. Big X represent the variable on the X axis. So your gradient is Q over P, your Y-intercept is P. Now, if you look at your y-intercept from the graph, we got 1.8. No problem, right? Your gradient from the graph, just now I got 0.388. Okay, let's just counter check 388. Is that so? Yes, 388. So I'm going to find the value of Q. Q is 0.388. Substitute P inside 1.8. 0.388 times 1.8, your P is 0.6984. Yeah, 0.6984. Okay, just so you know, for those who got 1.9 and just now I got 386, your Q will be 0.386 times 1.9. I got 0.7334. 7334. So there is a slight difference in answer depending whether you use 1.8 or 1.9, yeah, for your P. Okay. Okay. All right. So I think this is not too difficult. Let me just zoom out for you to see the graph once again. Okay. Okay, so let's continue with question number 12. So this is a very simple question from for chapter 9 solution triangle. So diagram 6 shows a prism ABCDEF given a length and breadth of the base of BCF is 12 and 5. So you're supposed to find the length of CD. Okay. Okay, we start by joining this together. We join this CD together. You can see that this is isosceles, equilateral actually. So it's 5, 5, and 5. They're all 5, but this is 5. This side is also 5. So if you want to find length of CD, we can use a simple Pythagoras theorem. Let me do it here. CD will be 5 square plus 12 square square root. Because this is a right angle, it's a prism. So answer is going to be 13. So you can use your calculator. Square root of 5 square plus 12 square square root 13. So very simple. The length of CD is just 13. Now, next you're finding the angle between BD and CD. BD and CD are two lines, okay, over here. Let me redraw this, BD and CD. So it is actually an isosceles triangle. So we know this is 13, with this 13. We are finding this angle. Here we can use cosine rule, but remember cosine rule is written like this, a square plus b square. Maybe I write here, a square equals to b square plus c square minus 2bc cos A. Normally, if you're finding 2bc cos A, if you're finding angle A, right, we rearrange it, bring the cos A to the left, bring the A square to the right, you divide by 2bc. So your B and C would be 13 and 13. Your A would be 15 because you're finding this angle D over here. So we write cos angle BDC. Your B and C are the same, right? So we write 13 square plus 13 square. Opposite length is 5 square, divide 2 times 13 times 13. So BDC will be, use your calculator, take 13 square, just times 2 will do. You minus 5 square is 25. 2 times 13 times 13. You can write 13 square. That will give us 313 over 338. We can just shift cos answer equals, write this down, 22.17. 22.17. Okay, that is your angle BDC, the angle between the two lines. Okay, next we're finding an area triangle. So very simple. Since we know this angle and we know the measurement of all three sides, we'll just use half AB sin C. We know this angle here is 22.17. Use formula for area triangle, half AB sin C, half 13 times 13 sine 22.17. Okay, use your calculator. Half 13 times 13, I write 13 square, sine 22.17. Be careful, your calculator must be in degree mode. Right? If you haven't changed your calculator mode, please change back to degree mode. Because sometimes when you're doing circular measure, use radian, then you forgot to change it back, right? So this is 31.89, yeah? 31.89. That is your area. Okay, now next we are finding the angle between plane BCD, which is a shaded plane, and BCFE. BCFE is the base. So if you're finding angle between the plane and the base, right, number one, you need to identify the intersecting line. The intersecting line between these two planes is BC. Number two, we're going to draw a 90-degree to each plane. So the first one, because this is an isosceles triangle, right, the red, yellow slanting plane is isosceles, so we can cut right in the middle. This would be a 90-degree. We draw another line, 90-degree to the base here, and the angle between them, okay, just join this together. This is a right angle triangle. You're finding this angle. So maybe I redraw for you in this direction. So it looks like this, where this is my D. Let's call this midpoint of BC as M. And let's call midpoint of EF as N. This is N. And we know the length of the base is 12. Now, actually, there are two ways. You can either find DM or you can find DN, either way. DN is the backline here, okay? Since FE, right, is also 5, right? Maybe I draw another one for you if you cannot see. This is DFE. This is 5, this is 5, this is also 5. You divide evenly the center. Let's call this N. This is 2.5. I need to find DN. So for my DN, we just use Pythagoras theorem, 5 square minus 2.5 square with a square root. Use your calculator. 5 square is 25, 2.5 square, you square root it. You should get 4.330. 4.330. That's your DN. 4.330. So once you got this, right, we can find angle between the line and plane, which is DMN. So We write tangent. Tangent DMN is opposite 4.330, divide adjacent 12. Okay, take this, divide by 12. Shift tangent answer. I got 19.84. So your angle DMN is 19.84. Yeah, angle between the line and the plane. Plane and plane, plane BCD and BCFE is 19.84. Okay, moving on to question number 13. So here we have a question on index number from 4 chapter 10. So table 3 shows the price indices in the year 2023 based on 2017 for 4 items PQ, R, and S used in the production of a pair of shoes and their weightages. So given that the price of material P is 3 ringgit in the year 2017, calculate the price in the year 2023. So these are the material that's used to produce a shoe. So we can start by taking the price in year 2023, divide by the price in 2017. 2017, the price is 3 ringgit, right? You can just write 3 here. Then, or 3.00 times 100, your price index is 140. So basically, you increase by 40%. Yeah, so we take 140 times 3 ringgit divided by 100, or 3 times 1.4, you get 4.24 ringgit and 20 cents. Okay, next. It is given that composite index for the year 2023 based on 2017 is 134.5. Find the value M. Composite index, you have to multiply each price indices with the weightage. So the first one is 140, you times 2M. Then we take 135, you multiply by 3. 120, you multiply by 1. 130 multiplied by M, divide by your total weightage, 2M plus 3 plus 1 plus M, answer 134.5. So let's simplify this. We take 140 times, okay, the 2M, I think no need calculator. Oh, okay, just times 2, and 130 times 1 times M is 130M. So we add this together first. This is 410M. And then for your 135, I must multiply by 3 plus 120 here. This will give us 525, 525. So this will be 3M plus 4 equals 134.5. So let's multiply over 410M plus 525, 134.5, 134.5. You multiply by 3 first. That will give us 403.5 M. And 134.5, you also need to multiply by 4. As you times 4, you get 538. So bring over 410 minus 403.5, you get 6.5 M. 538 minus 525 is 13. 13 divided 6.5. My M is 2. Okay, so I got my M already. Now, next, let's look at part C. Find the price of a pair of the shoes that in 2017, the corresponding price in 2023 is 45 ringgit. So here we are making an assumption that since these are the material that goes into the production of a shoe. So if the price or the cost gone up, then the selling price will also go up accordingly. So it's an assumption, but actually it may not necessarily be true because your cost plus your profit is equals to the selling price, right? So sometimes your cost may go up, your profit may have to go down just to maintain the same selling price, okay? Or your cost may have gone up, your profit go up, then your selling price will also go up. May not go up at the same rate. But here we are assuming that it's going up at the same rate, which is this 134.5. That means the price will go up by 34.5%. So the price in 2023 we know is RM 45 ringgit. The price in 2017 we don't know. You multiply by 100. Your cost has gone up by 34.5%. So we find the price in 2017. Take 45 times 100, divide by 134.5. Bring the P17 up, bring the 134.5 down. You should get 33.46. Round off. P17 is 33.46. Okay, last one, but D. Let me move up. If it is given that the price of material S is estimated to increase by 25% from the year 2023 to 24, other material remains unchanged. Find the composite index for 24 based on 17. Okay, from 23 to 24, this is 17, this is 23, this is 24. So material S, right, originally increased by 30% from 2017 to 23, yeah? But 23, 24 increased further by 25%. So we need to find what is the overall increase here. So we use what we call a simplified chain rule. 130 times 125 divide by 100. Let's take 130 times 125 divide 100. Answer 162.5. 162.5. Okay, so this material S has increased, but others remain unchanged. So when they remain unchanged, right, you're going to use back the same indices here. Because if you take, for example, 140 times 100 divided by 100 is still 140. It doesn't change. Same goes to Q135. Same goes to R120. So we're going to use the composite index now, right? The first one is 140. Remember, you know your M is 2. So this 2M is going to give us 4. And 135 you times 3 remains the same. 120 you times 1 remains the same. But the last one is going to be 162.5 because your price index for item S has increased, but your M is 2, sub inside. Divide by your total weightage. 2 times 2 is 4. This is 3. This is 1. This is 2. Now, let us calculate. So this is 140 times 4 plus 135 times 3, 120 times 1, and 162.5 times 2. Divide by your denominator is 4 plus 3 plus 2 plus 1 plus 1 plus 2 is also 10. Okay, you should get 141. There you go. That's your composite index for 24 based on 2017. Okay, question number 14. So here we have a particle that moves along a straight line, passes through fixed point. O velocity is given by this. You're finding the initial acceleration. Okay, remember, initial acceleration happens when your t is 0. But first, we need to find your acceleration function. Differentiate v, you get 6t minus 9. Substitute t with 0. Your a, put 0 inside. 6 times 0 minus 9. My a is negative 9. Yeah, meter per second. Okay, B, find the velocity when the particle stop instantaneously. Particle stop instantaneously when the v is 0, the velocity is 0. So we let your velocity function, this equals to 0. For me, I'll divide by 3 so that you get t squared minus 3t plus 2 equals 0. Double bracket factorize them. You should get t2 1 minus that. There are two values. T is either 1 or 2. Okay, still quite easy. All right, next. Calculate the minimum velocity attained by the particle. Okay, minimum velocity happens when the acceleration is 0. So probably if you draw the graph, it looks like this. The gradient here is 0. The gradient velocity time graph is 0. So we let A be 0. 6t minus 9 equals to 0. 9 divided by 6, t is 302. Take this 302, put inside your v. That will give us the minimum, right? Put inside your velocity function, 3 times 3/2 square minus 9 times 3/2 plus 6. Okay, use your calculator. Okay. For me, I just use 3/2 here. I press equals to store it as an answer. So 3 times answer square minus 9 times answer plus 6. I got negative 3/4. Yeah, meter per second. Okay. Now, lastly, you're finding the total distance traveled. Okay, for this question, I think it's better to do a sketch. We do a proper sketch of graph. Not to say, don't have to be perfect, but just a sketch like this, a velocity time graph. Okay, you know that the particle stop instantaneously at 1 and 2. By the way, I know it's a minimum curve because your coefficient of t square, your coefficient t square here, a is 3, is less than more than 0 positive. So it's a minimum graph, right? And area under the velocity time graph represent the total distance traveled. So you want to find this distance from 0 to 1, 1 to 2, 2 to 6. Remember, you cannot do one shot because part of the graph is below the t-axis is going to give us a negative value when you integrate. So you're going to do one by one. So the first part, I need to integrate 0 to 1. Your function is 3t squared minus 9t plus 6 dt. From 1 to 2 is going to be negative, so you put the negative in front to make it positive, or you can put a modulus, okay? So this is 1 to 2, 3t squared minus t squared plus 6 dt, and then 2 to 6, 3t squared minus t squared plus 6 dt. So the first part, when you integrate, you get t power 3 divided by 3, 9t squared divided by 2, 6t from 0 to 1. Same, the rest are going to be the same function after you integrate. So what we need to do is to sub in different limit. Okay, let me just write everything out first. 9t squared over 2, 60, 2 to 6. So we're going to put 1 inside, 1 minus 9 over 2. Okay, now you're expected to show your substitution. So you better write 1 power 3 because some teachers will mark you wrong for not writing all this. 6 times 1. Now here's the annoying part. I need to show 0 as well. Okay, this is so annoying. 0 square plus 6, 0, right? So the second I'm going to write next line. 2 power 3 minus 9 over 2, 2 square plus 6 times 2. Next, 1 power 3 minus 9 over 2, 1 square, 6 times 1. Okay, then you add the last part. Is going to be 6 power 3 minus 9 over 2, 6 squared plus 6 times 6, 6 times 6. And then you minus, this is going to be 2 power 3, 9 over 2, 2 squared plus 6 times 2. Okay, so now you can make it quite easy. Don't need to do so hard because you can use your calculator to calculate that. Let me show you how to use a calculator. There's this integration button here. You just type in the original function, 3x squared minus 9x plus 6. Your lower limit is 0, upper limit is 1. So you press equals. First answer is 5 2. Okay. Then you just change the limit. Second one, I'm going to change to 1 to 2. So 1 to 2 is going to be negative half. So it makes sense. The reason I put a negative in front because this area cannot be negative. I mean, area or distance travel cannot be negative, but it is negative because it is below. It simply means you're going to the left-hand side. This is 5 over 2. This is negative half. That's why I put a negative in front. You can even put a modulus. Third, I'm going to change from 2 to 6. 2 to 6 is going to give us 88. So this part is 88. So you just have to add them up. 5 over 2 plus 1 over 2 is 6 over 2. 6 over 2 is 3. 3 plus 88. Answer is 91 meter. Okay. All right, guys. Last question for this paper. So here we have a Harmony Community College offers Zapin and ballet dancing classes. Monthly fees per student are 30 and 60 ringgit respectively. The number of students for Zapin and ballet, X and Y, enrollment based on the following constraint. The total number of students not more than 40, so we put X plus Y less equals to 40. Okay, so total monthly fees collected is at least 1,200. So if you collect 30 ringgit for one student, so 30 times X is your total collection for Zapin. And then for ballet is 60, 60 times Y. At least we write greater equals 1,200. So for me, I'll divide everything by 30. So you get X plus 2Y greater equals to 40. Okay. Now, last inequality, the number of students enrolled for ballet. Ballet is Y, is at most. At most means less equals twice the number of students for Zapin. So less equals to X. So we have first inequality, second, and the third one. So you're supposed to write 3 inequality. Part A, we're done. Part B, they say using a scale of 2 cm to 5 students, build, construct, and shade a region that satisfy the constraint. So okay, I think I'll draw the scale first. They say 2 cm to 2 cm to 5 students. So it's 0. Let me zoom in. 0. This is 5, 10, 15, 20, 25, 30, 35, 40. So let's draw the axis as well. So this is your x-axis. Let's adjust this. Okay, this is x-axis. And do a y-axis there. This is 5, 10, 15, 20, 25, 30, 35, 40. I think a maximum is about 40. Yeah? Okay, I'll show you the table in a while. Let me just add this first. You can use the table of values to help you to draw your graph. Okay, I think we can stop at 40. I don't need to go more than that. Okay, so let's say the first inequality is x plus y equals 40. If you use the table of values, we start with x equals to 0. Right, let me zoom in a bit. Your y will be 40. Your y is 0. X is also 40. So 0, 40, 40, 0 should be a straight line. Let me draw it here. That passes through 40 and 40. So, okay, like this. So this is x plus y equals to 40. Okay, the second inequality is x plus 2y equals to 40. If you let x be 0, 40 divided by 2, y is 20. Y equals 0, x is 40. 0, 20, 40, 0. 0, 20, 40, 0. 0, 20 is here, right? 40, 0. Same point here. So looks like this. This is your x plus 2y equals 40. Okay, the third inequality is x. Let me write here, y equals to 2x. We use x equals 0, y equals 0. For the second point, you can use any point, any value. Maybe, let me see, x equals to 20 or 10. 10 will do lah. Y will be 20. Okay, so 10, 20 are very small. You can draw even longer. 0, 0 is here. 10, 20 is over here. So just extend the line. Make sure it passes through 20. Yeah. Okay. Let's see whether it passes through 20 or not. Adjust this a little bit. Maybe I can do a bit higher. Maybe do here because it looks easier to map. Yeah. Okay. It's 10, 20. Yeah. Around that. Okay. So this is y equals to 2x. Now you shape this region based on these three inequality. Number one, x plus y less equals 40. So I know it's below. Below is can be here, can be here. Then x plus 2y more than 40. More than 40 can be here, can be here. So it's quite clear. There are two possibilities. Third one, y less equals to x, that means it's below here. So we know it's actually inside. Inside this triangle here. Shade the region. Okay, this part you can erase, you don't need this, and label symbol R. Okay, right. Now with that, we need to solve the last part. Okay, look at parts here. They say if 10 students have been enrolled for ballet is Y, right? Find the range of values of number of students for Zapin. Okay, your Y is 10. Find your X. Okay, do a straight line. The dotted line, move across. Okay, zoom in a bit hard to see, right? Zoom in a bit. Okay, this is exactly 20. Then the second one is exactly 30. 20 and 30, yeah? All right, so we can say that the range of value is between 20 and 30. Okay. All right. Now, next, find the maximum total fees that can be collected in a month. Maximum total fees collected in the month. Okay, now we know the total fees collected is given by this 30x 60y. Okay, so let me write down the objective function 30x plus 60y equals okay. Yeah, that's the objective function. So we don't have to change y equals mx plus c in this case because we already know this line is parallel to the first line here, the 2x plus x plus 2y equals to 40. Yeah. Okay, so we're going to draw a dotted line. Okay, maybe I just draw a straight line first, then I adjust it. This is the first line. Okay, right. Wait, let me adjust a little bit. Okay, so this first line, right, is over here. We are drawing another line that is parallel to this line, but it gives us the maximum y-intercept because your k is maximum when the y-intercept is maximum. So I'm going to move it up and make sure it passes through a point in your region. Yeah, in the shaded region here. So it's around here. Okay, I had to adjust a little bit because number one, I use dotted line. Number two, take the vertex. Okay, so let me just adjust a little bit. You guys use your pencil and draw dotted line here. This is your objective function around here. Okay, so just move it up like that. Okay, so erase this. So this point is going to give us the largest y-intercept. Yeah, you don't have to find the y-intercept from the graph. You just have to find the coordinate. Okay, so if you read this coordinate, right, it looks like 1326. May not be exactly, oops, may not be exactly, sorry. Let me just go back to this one. It may not be because you may not get a nice coordinate. Okay, I think, right? Yeah. You can read, this is 26, right? It's not 26.5. You can't read 26.5. So it should be a bit lower. Okay, my line has to be a bit lower. You need to take what we call an exact coordinate, integer value. You can't take decimal point. So look at it. Can I go a bit further to the right? Can I read 14? 14 also looks possible. But you need to make sure it's inside. Okay, let me see. 14. This one is 14. 14 can actually. Yeah, 1426. If I do 13, 13 cannot, because 1326. 1326. 1326, yeah, it doesn't give us the largest y-intercept. Okay, sorry, yeah, I need to readjust this a little bit lower because it shouldn't be at the highest point. It's not exactly the highest point. Highest point is 26.75, which is not valid. We have to take the closest. Okay, maybe I draw one more time. Okay, I'm not going to use dotted line, but guys, you guys better use dotted line. Use dotted line, use your ruler, move it up. So let me show you here. Make sure it passes through this point. You see, if you take 13, right, it's lower. 13 has a lower y-intercept. 14 has a higher y-intercept. We can see that, 14. I can't take, yeah, this one is not 26.5 doesn't work. 27, can it be 27? Can it be 27? No, no, this one is not 27. Okay, one of the things we can do to double check is that we can take this equation. This equation is x plus 2y. X plus y equals 40. If you take 2 x plus y is 2x equals to 40. 40 divided by 3. What is 40 divided by 3? 40 divided by 3 is 13.33. So 13.33. So this point actually intersects 13.33, and your y will be times 2, 26.66. So you cannot exceed 26, right? You can go more than 13 actually because it can be over here. This is 14, right? So you cannot read 13 point, I mean, we can't go beyond 26. So my answer is going to be 14, 20, 26. Yeah, 14, 26 is possible. It's inside here. Okay, I hope you can see that. Yeah, move down is 14, right? Yeah, 14 makes sense. 14, 26. Okay, so coming back to your objective function. So from the graph, right? From the graph, your k is maximum at 14, 26. To find the maximum value k, we substitute 13 and 1426 inside your x and y and find the maximum fees collected. So we take 30 times 14 plus 60 times 26. You will get 1,980. Right? I think the answer given is a little bit different because they use 1326. I think 1426 is actually more accurate. Okay, so that's your answer. I zoom out. Yeah, I think it's okay. I just zoom here. All right. So I hope you guys learned something in the process of this discussion of this paper, right? So hopefully it will help you in your trial exam in your SPM. Thank you for watching. Hope to see you guys in the next video.